We're going to be starting chapter 3 today, which is over polynomial and rational functions. And today specifically, we'll be talking about quadratic functions in 3.1. Our objectives are to recognize the characteristics of parabolas, graph parabolas, determine a quadratic function's minimum or maximum, and solve problems involving the minimum or maximum. So a parabola can be going upward, it could be going downward. Kind of looks like an arch. So those are the shapes we're going to be looking at today. This is going to be the standard form that you're going to want to memorize. So you'd have f of x equals a times the quantity x minus h squared plus k, and a cannot equal 0. So this is the graph of a parabola. The vertex is the point hk. So this would be the x-coordinate of the vertex, and this would be the y-coordinate of the vertex. The parabola is symmetric with respect to the line x equals h. And if a is greater than 0, the parabola opens upward. And if it's less than 0, so that would be a negative number out front, the parabola is going to open downward. So if you see a negative out front, you know automatically it's going to be a downward parabola, upside down. Okay, now we'll talk about how we can graph this if it is in standard form. So first you have to determine where the parabola is going to open up or down. So again, if it's positive, it's going to open up. If it's negative, it's going to open down. Then you'll determine what the vertex of that is, and that's the h and the k in the formula. And then you'll find any x-intercepts by solving for when f of x equals 0. And the function's real zeros are going to be the x-intercepts, so where it crosses the x-axis. Your fourth step is to find the y-intercept by solving f of 0. And then 5, you'll plot the x-intercepts and y-intercept, the vertex, and any additional points that are going to help you draw your curve. So again, the parabola should be a smooth curve shaped like a bowl or an upside down bowl. So let's go ahead and try one step by step. So we have negative, then we have x minus 1 in parentheses squared plus f, or 4. So in this one, the a is right here. So in this case, it's negative 1. So if there's no number, you can put a 1 there. So this is negative 1. So a is less than 0, so the parabola opens downward or upside down. Step 2 is to find the vertex. So the vertex is where the h and the k are located. So if you look here, the h is going to be this 1 here. So we already had a subtraction. So that means that this is just a positive 1. And then the k is the number at the end, and it's positive 4. So the parabola has its vertex at 1, 4. So that's going to be either the highest point of the parabola or the lowest point of the parabola. Now we said this one is opening downward, so the vertex is going to be the maximum, which is going to be at 1, 4. So if it opens downward, it's going to be the maximum point, the highest point on that parabola. Now we'll find the x-intercept. So to do this, you're going to solve for f of x equals 0. So if you notice, I replaced this with 0. And now all I have left in the equation is x's. So that's how I know I'm finding the x-intercepts, because I have nothing left but x's in the equation. Our first step is going to be to subtract the 4. That gives us negative 4 equals negative x minus 1 squared. And I'm going to make this a negative 1 just to make it a little easier when we go to the division step. So I'm going to divide by negative 1 to get rid of these. So negative 4 divided by negative 1 is positive 4. And we still have x minus 1 squared in parentheses. So to undo that squared, we're going to have to take the square root. So that gives us positive or negative 2 equals, now these symbols cancel each other out. So I just have the x minus 1 left. You don't need the parentheses anymore. So now to write this, I have either 2 equals x minus 1, and I have negative 2 equals x minus 1. So let's go ahead and solve for x. Add 1, we get 3 equals x. And the other one, add 1, you get negative 1 equals x. So remember in your coordinate, the x comes first in the y. So one of our x's is 3, the other one is negative 1. So if this is talking about an x-intercept, if I go over 3 on the x-axis, that coordinate is 3, 0. It doesn't go anywhere on the y. And same with the negative 1. That's going to be negative 1, 0. So my x-intercepts are 3, 0, and negative 1, 0. Step 4, we're going to find the y-intercept by solving for f of 0. So that means I'm going to replace any x I see with a 0. Because this time we don't want any x's left because we're trying to find the y. So I'll put a 0 in here. So that leaves me with negative 1 squared plus 4. Negative 1 times negative 1 is positive 1, but then I still have that negative out front, so be careful with that. Negative 1 plus 4 is 3. So the y-intercept, I'm trying to figure out where it hits the y-axis. So I'm saying it's going to hit at 3. So this coordinate is 0 on the x, 3 on the y-axis. So 0, 3 is how you would write that. In step 5, we're going to graph it. So we know it's going to be opening downward. We found our x-intercepts earlier were 3, 0 and negative 1, 0. So that's where these red points come into play. The y-intercept is 0, 3 right here. And then our vertex, I mentioned this earlier, is going to be the maximum of the parabola. So 1, 4 is right here. So that's enough points where I'm going to be able to make a good parabola. If you're going to have a hard time making it, then you might want to pick another point just to try making a table of values. But this one, we found both x-intercepts and a y-intercept, so it's pretty easy to graph after that. Okay, let's try another one of those. So this one, out in front, I have nothing, so it's just like a 1. So a equals 1. And sorry, this should say a is greater than 0. So the parabola opens upward. So if it's a positive number, it's going to be opening upward. Okay, now we'll find the vertex. That's HK. So the H, now be careful with this negative here. The only way that this could have turned into a positive 3 would have been to subtract a negative 3. So that means the H was negative 3. And then my K value is plus something, so in this case it's plus 1. So my vertex is negative 3, 1. Okay, so the x-intercepts, we're going to have f of x equals 0. So replace this with 0. So all I should have left in the equation are x's. So I'm going to subtract 1. Gives me negative 1 equals the quantity x plus 3 squared. And now I'll take the square root. Okay, so we're running into an issue here. So If you work with imaginary numbers, you know this is going to say error. So I'd have this equals an imaginary number, then I have x plus 3 left. So you could finish solving that, but I'm going to have a positive or a negative of the I. So I equals x plus 3, and negative I equals x plus 3 minus the 3. So I get the imaginary number minus 3 equals x, or the imaginary number, a negative imaginary number minus 3 equals x. What you're going to see is it has no real solutions. We could get into the imaginary number system, but we're not going to need to go there for this lesson. So the parabola has no x-intercepts. And we'll see what this looks like in the graph, but it just means it's not going to hit the x-axis ever. And the graph is going to be opening upward, and it's not ever going to hit the x-axis. Okay, let's see if it does hit the y-axis though. So for this one, we're going to solve for f of 0, so replace every x with a 0. So that's just going to be 3 squared plus 1. Oops, jumping ahead of myself here. Which equals 9 plus 1, which is 10. So it's going to hit the graph at 0 on the x-axis and 10 on the y because it is the y-intercept. Okay, so we already said that it opens upward. The x-intercepts are none. We just said the y-intercept was 0, 10. So let's go ahead and graph that point. It's going to be right here. And then we had said earlier on the vertex was negative 3, 1. Okay, so the vertex is going to be where it's right down the middle of the parabola. So if you look at that vertex, this point is 1, 2, 3 away, so I can go 1, 2, 3 away this way and put another dot. And then I'm going to have a symmetrical parabola. So as long as you have 2 points and you know one of them is the vertex, then you could just reflect it over to find a third point. Or you could always make a table of values. Okay, now we're going to have it just in a different form. This is going to look more like a quadratic equation where it's not factored, it doesn't have any parentheses in it. So a quadratic function, f of x equals a times x squared plus b times x plus c. The parabola's vertex, you have to take negative b divided by 2a. So you're going to have to take the b divided by 2 times the a and then make it its opposite. And the x-coordinate can also be found by that negative b divided by 2a. This also helps us find that reflection line, that axis of symmetry is what it is called. And then the y-coordinate is found by substituting the x-coordinate into the parabola's equation and then solving the function for that x value. Okay, so just this highlights those steps again. Step 1, determine if it opens up or down. 2, find the vertex. And that also helps you find that reflection line. Number 3, find any x-intercepts by solving for f of x equals 0. Step 4, find the y-intercept by solving for f of 0. So these steps should look familiar. And then 5, plot the intercepts, the vertex, and additional points as necessary. Okay, so first we know this in front we have our A, B, C value. And you always want to make sure it's in the right order. The A should be the squared term, the B should be the X, and the C should be the constant term. Just a normal number with no letters. So in this one, the A is just what's out front. Again, that would be a -1. It is less than 0, so the parabola opens downward. Step 2, find the vertex and axis of symmetry. So we're going to use this formula. We're going to take negative b over 2a. So the b is 4. And we have 2 times -1 is the a. But then make sure you do the opposite of that at the end. So that negative could be on the top or the bottom. I just tag it out front for now. So I have -4 over -2. So these negatives will cancel into positives and give us a +2. So this is our x value. X equals 2. So now that we know that, we need to know, well, what is the y value when the x is 2? So we need to try to find y coordinate of the vertex. We're going to find what f of 2 is. So if I look back at my equation, I'm going to replace all the x's with 2's. So I'd have 2 squared plus 4 times 2 plus 1. So that means I'd have -1 times 4 plus 8 plus 1, which is -4 plus 8 plus 1, which gives me 5. So my y equals 5. So my vertex is going to be 2, 5. And this axis of symmetry is going to tell us that on my graph, on the x equals 2, I'm going to have my dividing reflection line. And my vertex is at 2, 5, so somewhere up here. And I'm going to have that reflection line going through that. Okay, and I guess I jumped ahead of myself, so we already found this. I didn't know I had a second slide here. So we just said the vertex when we solved for x equals 2 was 2, 5. Okay, next step, find the x-intercepts by solving f of x equals 0. So you could try to factor this, but you're not going to be able to. So I went ahead and threw in the quadratic formula, and we use this for quadratic functions. So it's -b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is our a, b, c value. So instead of f of x, we're trying to figure out what x values will make this equal 0. So the a is -1. Okay, so let's go ahead and try to solve this. So I'd have -b, so that'd be -4 plus or minus, the b is 4 squared minus 4. The a is -1. The c is +1. All over 2 times a, which was -1. So that will give us -4 plus or minus the square root of 16. I have a double negative here. So really I just have 4 times 1, which is 4, and it's +4 because it's positive, all over -2. Okay, so here is why this isn't going to be factorable, because you're going to get -4 plus the square root of 20 divided by -2, and The other option is -4 minus the square root of 20 divided by -2. So here's what I would do on your calculator. Because we don't want to round off the square root of 20 unless we absolutely have to. What I would do is plug in the top first. So do -4 plus the square root of 20. Press the equal sign. Then press divided by 2, and you should get x is about -0.24. And then for this one, you do -4 minus the square root of 20, press the equal sign, then divide by -2, and you should get about 4.24. So those are my x's. So one option is -0.240. The other one is 4.240. Step 4, find the y-intercept by solving f of 0. So replace the x's with zeros. So I'd have -0 squared, which is just 0, plus 4 times 0 is 0, plus 1. So it just equals 1. So my y-intercept is 0 on the x-axis, 1 on the y-axis. And then we'll go ahead and graph. So they rounded to the nearest tenth here instead of hundredths place. We had -0.24, so we have that right here. Then we have about 4.2 right here. We said the y-intercept was 0, 1. That's where this point comes in. The vertex is the 2, 5. And then our axis of symmetry, again, we said earlier, is going to be that line that divides the parabola down the middle. It's wherever your vertex is at. So that is also x equals 2. Okay, and review of domain and range. So the domain is all the possible x's. So on the x-axis, this is eventually going to go to -infinity. It never stops. To positive infinity. And the range is all the y values. So you can see my maximum point is here at 5. And it goes down into -infinity on the y-axis. So I'd have -infinity up to +5 is the maximum, and it can include that, so close it off with a bracket. So we've already mentioned this a little bit, but if the a is greater than 0, then you're going to end up with a minimum value because the graph is going to open upward. So this right here is a minimum, the lowest point of the parabola. If a is less than 0, the f is a maximum because it's an upside down graph. So if I do this, this point is a maximum because it's the highest point of the graph. And the value of x equals -b over 2a gives the location of that minimum or maximum because it is the vertex. It's going to help you find the vertex of it. Okay, so here is our equation, and determine without graphing whether the function has a minimum value or a maximum value. So the a is this +4, which is greater than 0, it's positive. So the function is going to have a minimum value because the graph will be opening upwards. So it's going to be a minimum down at the bottom. Okay, now let's also figure something else out about this graph. Find the minimum or maximum value and determine where it occurs. We already said it's going to be a minimum. So we want to know where that is going to occur at. So we said we can use that x equation, which helps us find the vertex and the axis of symmetry. So here's my A, B, C. So I'd have B is -16, careful there. Then A is 4. So I'd have this double negative turn into a positive 16 over 8, which is 2. And we said that was for x. So x equals 2. Okay, so now we need to go ahead and plug in, if x is 2, what do we get for the y? So we find f of 2. So replace every x in the equation with a 2. So I'm going to get 4 times 4 minus 32 plus 1,000. That's 16 minus 32 plus 1,000. You end up getting 984. So the minimum value is 984. It occurs at x equals 2, so the coordinate is 2, 984. That is our vertex. Which is our minimum value for this parabola. Okay, now let's look at that function again. Identify the function's domain and range without graphing it. So the domain for all these parabolas, the x's are going to be -infinity to +infinity. We found that the vertex is at 2, 984. And we said that the a is greater than 0, so the function has a minimum value at the vertex, and it opens upward. So imagine this is the vertex, it's 2, 984. So this is definitely not drawn to scale, but just imagine it's 2 over and then it's going to be way up. Maybe I'm going to count by hundreds or 500s on the y-axis. So the range is going to, the bottom y value, that's 984. And then it goes all the way up to +infinity. So sometimes drawing a visual, I think, helps make sense of these problems a little better. Okay, so now we're going to talk about maximizing or minimizing quadratic functions. So read the problem carefully, decide which quantity is to be maximized or minimized, use the conditions of the problem to express the quantity as a function in one variable, then rewrite the function in the form f of x equals ax squared plus bx plus c. Then you'll solve for that negative b over 2a again. If it's greater than 0, it's a minimum. If it's less than 0, it's going to be a maximum, and then you would answer the question. So this involves some area and perimeter problems. I'm not going to have one like this on the test for you, so there is an example in the book that you can look at. If you want to just see how to do one of these, it's example 6 in the book. Okay, so let's end with an application problem. So this is talking about a punted football, and here is our function to model that. X is the ball's horizontal distance in feet. So you can see that from here after it hits the kicker's foot. So A says, what is the maximum height of the punt and how far from the point of impact on his foot does this occur? So we're trying to find the maximum height of this parabola. So if we imagined this graph, it's going to keep going. It's not going to be drawn to scale, but it's eventually going to hit a maximum here. So we're trying to find that maximum value, which is the vertex. So again, just try to think of it as a real life situation. If you're punting the ball, you're going to eventually hit a maximum and then it's going to start soaring down again. So let's go ahead and find what our maximum height of the ball is going to be. So I'm going to use the x equals negative b over 2a. Here's my a, b, c. I'm going to have negative 1.18 over 2 times negative 0.01. So you end up getting a positive 59 after you plug this into the calculator. Okay, so now if we know the x, we're going to try to find what is f of 59. So if I replace all the x's with 59, what am I going to get? So here's my formula. Replace all my x's with 59. Plus 2. And when you plug all that into a calculator, you're going to end up getting 36.81. And I should mention this is feet. So our vertex is going to be, which is our maximum, 59 feet. On the x-axis, 36.81 feet on the y-axis. So if we look at our visual, the 59 is going to be on the x-axis, which is the distance from the point of impact. So there's where the 59 feet goes. And then the y is the height of the punted football. So the maximum height of the punt is the 36.81 feet. Okay, next, how far must the nearest defensive player, who is 6 feet from the kicker's point of impact, reach to block the punt? So we're wanting to know, how far does he have to reach? So his height or his jump. And he's 6 feet from the kicker's point of impact. So he's right here at 6 feet. So we're trying to find, okay, well, where does that, how far is he having to leap? What is this point up here? So you can estimate it, but we're going to actually find the exact amount. So we're trying to find when the x is 6. So what is f of 6? So I'm replacing all my x's with a 6. So I'd have negative 0.01 times 6 squared plus 1.18 times 6 plus 2. And when you solve that out, you get negative 0.36 plus 7.08 plus 2, which is 8.72 feet. So that's how far he has to jump or reach to block the punt. Okay, part C, if the ball is not blocked by the defensive player, how far down the field will it go before it hits the ground? So let's say this guy here doesn't block it and the graph just keeps going. When is it going to hit the ground? When is it going to be 0 for y? 0 feet. So I put, to find the horizontal distance x, when the height f of x is 0 feet from the ground. So we're trying to find when this f of x equals 0 feet. So we're setting our equation equal to 0 and trying to find what is our x value. How far did it go down the field from the point of impact? So this one you're definitely going to want to use the quadratic formula because we have so many decimals here. You're not going to want to try to factor this. So if you remember that it's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So I have my a, b, c. So negative b would be negative 1.18 plus or minus 1.18 squared minus 4 times a is negative 0.01 times c is 2. And that is all over 2 times a is negative 0.01. So we have a lot to do in a calculator here. We'd have negative 1.18 plus or minus. If I put all the inside stuff together, you're going to get 1.4724. And on the bottom, you get negative 0.02. Okay, so one option for x is x equals negative 1.18 plus the square root of 1.4724. So you're going to put that in your calculator, then divide by negative 0.02, and that gives you negative 1.7. But we're talking about feet. So this one is not a possible value because we can't have a negative amount of feet. So let's try the other one. X could be negative 1.18 minus the square root of 1.4724. I'm sorry, I'm running out of room here. Negative 0.02. If you plug that in a calculator, you get about 119.7 feet. So it's going to eventually go down the field. How far down the field will it go? It's going to go 119.7 feet down the field before it hits the ground if nobody blocks it. Okay, last slide. So now we're going to graph it. So the vertex, which is also the axis of symmetry, we said the vertex was 59 feet and then 36.81 feet. So you can see this little gray dot here. I'll make it blue. That's 59 feet down the field and 36.81 feet high. So this is the height of the football. Okay, the x-intercept, you end up hitting, we said around, it was 119.7 or about 120 feet. So that's where it hit the x-axis. Then the y-intercept, if you look back at this picture, do that in green. You can see where he hits it off the ground is 2 feet. So it's 2 feet off the ground when he hits it. So that's why this original equation had that +2, because it's starting 2 feet above the ground. And that would be what the graph looks like. So again, I think these application problems are very helpful when you have a visual and you're actually trying to understand what each point means. And that's the end of that video.